This video covers Lesson 7-3 for Secondary 1 Math, the Pythagorean Theorem and the distance formula. So we're going to solve for the missing side length. Write your answer as a simplified radical and as a decimal rounded to the nearest tenth if necessary. So the first thing we're going to do is identify what our hypotenuse is. So remember, the hypotenuse is across from the right angle. So in this case, number 1, it's going to be 50 meters. And then A and B are interchangeable. So now we're going to write our Pythagorean Theorem equation. So substituting in what we have, a squared plus 48 squared equals 50 squared. Now we're going to use our calculators, and we're going to find 48 squared and 50 squared. So our equation would be a squared plus, and then 48 squared in our calculator was 2,304 equals 50 squared, which is 2,500. Then we're going to subtract the 2,304 from both sides of our equation, which gives us that a squared is equal to 196. Now take the square root, and we find that a is equal to 14. And since it comes out nice, there's no reason to find a decimal approximation. This is our simplified radical, so a is 14 meters. And I'm going to write this over here for a, 14. Number 2, we have the right triangle with leg lengths of 8 and 10. And our hypotenuse, C, is what we're going to solve for. So substituting what we know into our Pythagorean Theorem equation, we get 8 squared plus 10 squared equals C squared. Now 8 squared is 64, 10 squared, 100. We know that's equal to C squared. So 164 is equal to C squared. Now we're going to take the square root of both sides. That gets rid of our square. So we get C equals, now this one might not come out right. Let's go ahead and put in our calculators the square root of 164. And we get 12.8 as our decimal approximation. So I'm going to go ahead and change this equal sign to an approximate sign. Now we want to look for the exact, so the simplified radical expression, right, for the square root of 164. So to do that, I'm just going to do a little scratch work here in the middle. So 164, it's divisible by 2. And if we divide 164 by 2, we get 82. And then if we divide that by 2, we get 41. And 41's prime, and we have a pair of 2's that will be our prime factors. So we're going to have 2 square root 41, and then we'll have it in inches, is our simplified radical answer. So approximation is 12.8 inches, and the simplified radical answer is 2 square root 41 inches. Here is a little note. It says perimeter is the sum of all the side lengths. So number 3 says find the perimeter on number 1. So we're just going to add all the side lengths together because we're finding the sum. So we have 14 plus 48 plus 50. And if we add all of those together, we get 112 meters. Again, we're including our units. Number 4, find the perimeter of number 2. So again, we're just going to add all the side lengths. So we got 10 inches plus 8 inches plus C. Now, we could use the simplified radical, but instead we're going to use the approximation so we can add it. Otherwise, we won't be able to. So 10 plus 8 is 18, plus 12 is 30, and then we have the 0.8. So it's 30.8. Include our units, inches. Now we're going to shift gears a little bit, and instead of talking about perimeter, we're going to talk about area. So remember, the area is the size of a surface. So finding the area of a rectangle, we would do base times height or length times width. If it's a triangle, we do base times height, and then we just multiply it by 1/2, because a triangle is half of a rectangle. If it's a parallelogram, we're going to do base times height. Now, a parallelogram looks like this. Okay, something like that. Parallelogram. Then the trapezoid is 1/2 times height times b1 plus b2, or base 1 plus base 2. So a trapezoid could look something like this. Okay. So here's our base 1, this is base 2, and then you have your height, this distance from base 1 to base 2, and you cut it in half. Also, with the parallelogram, we have our base here, and our height is that distance. Okay, so what our goal is in number 5 is to find the area of number 1. So we're dealing with a triangle. So the area of that triangle, A, is 1/2 times the base. Now we've got to decide what the base and the height are. So if we go look at our triangle, notice that we have a right triangle. So I'm going to put this in yellow here. Here and here are the base and the height. Now it might be helpful to flip your paper around so you can see it. But if this is our base right here, I'll label it this way here, base, then this is the height of that same triangle. If we were to extend this out, we could form a rectangle, and it's going to be half of that base and height of that rectangle. So we're going to use 48 as our base and 14 as the height. So we have 48 times 14. And when we put this into our calculator, 1/2 times 48 times 14, we get that the area of this triangle is 336 meters squared. Now, as a reminder, meters squared because we have 48 meters right here times 14 meters. And meters times meters is meters squared. So the area of the triangle in number 1 is 336 meters squared. Number 6, find the area of number 2. So again, we're dealing with a triangle. So we're going to go ahead and set that up. A is equal to, the area is equal to 1/2 times, we're going to look at our base and our height. So remember, the legs are our base and our height. So we have 8 and 10. So it's 1/2 times 8 times 10. So 1/2 times 8 is 4, times 10 would be 40. So the area of this right triangle is 40 inches squared. Okay, we can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So number 7 asks us to plot these 2 points. We have A, -4, 5. So starting at the origin, I'm going to go left 4 to -4 and up 5. That's our first point. And B, so label that A. And B is 2, 1. So we're going to go right 2 from the origin and up 1. So this point here, and that's B. Number 8, find the distance between the 2 points. Now we can change that question by drawing a line segment from A to B and saying, hey, what's the length of that line segment? Well, that's still not very helpful. It's hard to determine that. So let's add a few other things. We know that we could talk about the distance it is vertically and horizontally. So going down from A to B, we would move down 4 units. And we would move to the right just like we would do a slope, 1, 2, 3, 4, 5, 6 units. And now we've created, do you notice this? A right triangle with one leg being 4 units and the other leg being 6 units. And we can find C, or our hypotenuse of this right triangle, which is the distance from A to B. So using the Pythagorean Theorem equation, we can set this up. And we'll have 4 squared plus 6 squared is equal to C squared. Now our problem didn't ask us for C, or the value of the hypotenuse. It asked us for the distance from A to B. So we're going to replace C squared, and we're actually going to write this as AB squared. Right? Which means the distance from A to B squared. Now we're going to solve this Pythagorean Theorem equation just like we would normally. So we're going to take 4 squared, that's 16, and we're going to add 6 squared, which is 36. So adding those together, we get 52. So 52 is equal to AB squared. So now we're going to take the square root of both sides of our equation. Using our calculators to find the square root of 52, we get that AB is approximately 7.2 units. Now we want to find the exact value of the distance from A to B. And so we've got to simplify this radical expression, square root of 52. So 52 can be factored to 2 and 26, which can be factored to 2 and 13. And so notice we have a pair of 2's. So we're going to have 2 square root 13 units. So the distance from A to B is 2 root 13 units, or approximately 7.2 units. Okay, number 9. So here it says, how can you find the distance between the points without using a graph? So if we look above, just to kind of visualize what's going on here, we first, in this first problem, number 8 or 7 connected, we know that this change of 6 is our change in x, because it's the horizontal change. It went from -4 to +2, and that was a change of 6 in x, going from A to B. And then this 4 was our change in y, right? It was that vertical change as we went from A to B or B to A. So it's a distance of 4. So likewise, we just need to find the change in y and the change in x, like our slope. And given 2 points to find our slope, we talked about how we start at 1 and we go to the other. So if I start at -4 and go to 1, that means I need to add 5. And our change in x, -5, plus what is 2? Well, I need to add 7. So we're saying that our change in x, right, is 7. The change in y is 5. And those are the lengths of the legs of our right triangle. So I could just draw myself a little triangle, say, well, this one is 7 units, and this one is 5 units. Now, setting up our Pythagorean Theorem equation, we would have 5 squared plus 7 squared is equal to mn squared. Now again, I replace the c in our Pythagorean Theorem equation with mn squared. So 5 squared is 25, 7 squared is 49, and then we're going to have that be equal to mn squared. Add those together, and we get 74 is equal to mn squared. And then we're going to take the square root of those, and we get that mn is approximately, putting this in our calculator, square root of 74 in our calculator, we get about 8.6 units. Or we can simplify, right, our radical expression, the square root of 74. So 74 factors, it's a 2, so that's going to be 37. and 37 is prime. So I can't do anything. So mn is equal to the square root of 74 units. So we have our approximate and exact distance from m to n. Okay, so this highlighted information on the left is helpful because it's going to help us identify the distance formula. And the first highlighted thing on the left compares to what we wrote here on the right. 5 squared plus 7 squared equals mn squared. Now the difference is that they replaced mn, the way we've written it, with d. And d stands for distance. So d is distance. Now, they got 7 and 5 the same way we did, although they switched the order, and that's fine. Now, 7 and 5 really, remember, were the change in x and the change in y. And so they're going to rewrite that on the next line, okay, with change in x squared plus change in y squared equals d squared. Then, to go to the next line, they saw that, hey, we got d squared. And to undo d squared, we're going to take the square root. So they took the square root of both sides and got the square root of the change in x squared plus the change in y squared is equal to d, or the distance. So they're at this point and they say, okay, what's the change in x? Well, they refer back to this formula here, I'm putting a box around, which is our slope formula, where we're finding y2 minus y1, or x2 minus x1. We're finding the change in the y values and the change in the x values. And so instead of writing change in y and change in x, they said we're going to replace that, or substitute in y2 minus y1 for the change in y, and x2 minus x1 for the change in x. And when they do that, they get the distance formula. And this here's the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, we're going to use this distance formula to find the distance between 2 points. So the directions for 10 and 11. Find the distance between each set of points using the distance formula. Write your answer as a simplified radical and as a decimal rounded to the nearest tenth if necessary. So we're just substituting into this formula. So we need to know, hey, what's x1 and what's x2? What's y1? What's y2? So the x1 would be 3. So we're just going to label it right above it. 3 is x1. That means 9 would be x2. And then 10 would be y1. And 24 will be y2. Now, we're just going to substitute them into this formula. So we have d is equal to the square root of 9 minus 3, because we did x2 minus x1 squared, plus y2, which is 24, minus y1, which is 10, squared. Now, to solve for the distance d, we're going to do 9 minus 3, which is 6. We'll have 6 squared, plus, then we have 24 minus 10, which is 14 squared. Then we're going to square these and then take the square root. So the distance is going to be the square root of 36 plus 196. If we add those together, we get 232. And then we're going to take the square root of that. So the square root of 232 is our distance. So what we need to do now is we need to find that approximation. So just type it into your calculator and see if it comes out exact or as an approximate. Once you've typed it in, you should get D is about 15.2. And we'll say units because we don't know what the units are. Now we want the exact, so the distance, the exact distance, we've got to take 232 and do the prime factorization. So I'll put that in blue. 232 prime factorization, we got 2 and 116, and 116 would be 2 and 58, and 58 factors to 29 and 2, and 29 is prime, so is 2, so we're going to get a 2 out of our square root and leave the 58, or 29 times 2, which is 58. So we get that D is 2 root 58. And again, that's in units as well. We don't know what the units are. Number 11, we have the point -9, and -112. So again, just label these. We have x1, y1, x2, y2. Substituting these in, we get that the distance is equal to the square root of -1 minus -9 squared plus 12 minus 0 squared. So simplifying our inside the parentheses, we find that the distance is equal to the square root of 8 squared plus 12 squared. So the distance is equal to 64 plus 144. Adding those together, we get that the distance is the square root of 208. Now, typing that into our calculator, we'll see if it comes out exact or if it's an approximation. We find that D is about 14.4 units. Now we've got to simplify our square root. So we've got to take 208 and prime factor it. So we'll go 2, 104. Then we can go 2, and that would be 52. Then we divide 52 by 2, and we get 26. And 26 factors to 2 and 13. 13 is prime. So now we're just going to look at what pairs we have. Okay, so we have 1, 2, 3, 4 2's. And so we're going to pull out 2 pairs of 2's, which will give us 4 root, square root 13. So the distance is exactly 4 square root 13 units. Alright, number 12. Given the vertices of a triangle, find the length of each side. Write your answer as a simplified radical and as a decimal rounded to the nearest tenth, if necessary. Now, here, we've got to find every pair. So what we're going to do is we're going to first find the distance from A to B. So I'm just going to do AB is equal to, and then we've got to do the others. So then we'll do AC, and then we'll do BC. So let's go ahead and do AB first. So AB, so we're looking here, we have x sub 1, y sub 1, x sub 2, y sub 2. So we've got the square root of 3 minus 5 squared plus 3 minus -4 squared. So AB is equal to the square root of -2 squared plus 7 squared. So AB is equal to 4, the square root of 4 plus 49. So that's, AB is then the square root of 53. Square root of 53. Is it divisible by, not divisible by 2 because it's odd, not divisible by 3 because 52 is divisible by 3, or 5 or 10, that's prime. So we can leave it at that. We just need to get the approximation. So there's our exact distance from A to B. Now our approximate distance, we're just going to use our calculators, type in the square root of 53, and we get 7, round to the nearest tenth, 0.3. Now let's do AC. So AC, we're going to go ahead and label, we got x sub 1, y sub 1 in A, and then we'll do x sub 2 and y sub 2 in C. So we have the square root of negative 1 minus 5 squared plus negative 2 minus negative 4 squared. So simplifying, AC is equal to the square root. In our parentheses we get negative 6 squared plus negative 2 minus negative 4 is like negative 2 plus 4, so 2 squared. So AC is the square root of 36 plus 4, or AC is equal to the square root of 40. Okay, now we got to look to simplify that radical expression. So 40 factors to 4 and 10, and then 4 is 2 and 2, so we're going to get a 2 out, and then we have 2 and 5. So we're going to have a pair of 2's. The distance from A to C as a simplified radical expression is 2 root 10, or 2 square root 10. Now putting it in our calculators, just type in the square root of 40, and we'll get that approximation, which we get that AC is about 6.3 units. Alright, so we have one side length left, and I'm going to have to erase some of my work here so that I have space to do it. So I'm going to erase the AB work. I'll put that back up at the top and use that space. Okay, so I've erased that, put AB up here at the top of the problem. Now BC, to find that distance, we're going to do the square root. We're going to substitute in. So let's go ahead and label B as x sub 1 and y sub 1. And C will be x sub 2 and y sub 2. Now we're going to substitute in those values. So we have x sub 2, which is negative 1, minus x sub 1, which is 3, squared, plus, parenthesis, y sub 2, which is negative 2, minus y sub 1, which is 3. Or raise that to the second power. Now we're going to go ahead and simplify this. So BC is equal to the square root of negative 4 squared plus negative 5 squared. So BC is equal to the square root of 16 plus 25. And 16 plus 25 is equal to 41. So BC is the square root of 41, or the distance from B to C is the square root of 41 units. Now you might be asking why I didn't find the prime factorization of 41. Well, that's because 41 is prime, and so I knew that we would leave it as the square root of 41 units. But I do need to put it in the calculator, so if we take square root of 41 and put it in the calculator, we find that the approximate length of BC is 6.4 units. So right below this, there's some helpful videos that you can find on YouTube, just going online. You can check those out and see if they are helpful to you. One for Pythagorean Theorem, the other for the distance formula. This concludes the video of Lesson 7-3 for Secondary 1 Math, the Pythagorean Theorem and distance formulas.